Hi, and welcome to this section of the Chemistry Tutor. In this section, we're going to cover the topic of hydrate compounds. So one thing you got to get through to yourself in chemistry is that almost everything has a very intimidating sounding name. This is one of them, hydrate compounds. It sounds, whoa, what's this? It's a new type of compound, so complicated. You're going to find out here it's very, very simple. Ask yourself, what does the word hydrate mean? If you're riding a bike and you need to hydrate yourself, what does it mean? It means you need water. So hydrate compounds somehow involve water. What it basically boils down to is a hydrate compound. I could write this on the board, but it's really so simple there's no need to. A hydrate compound is just an ionic compound, which is what we've been talking about the last couple sections. It's a regular old ionic compound with a fixed number of water molecules tied up in the lattice structure. In other words, you might have, calcium chloride or something like that, and it's a regular arrangement of calcium and chlorine ions in a rectangular rigid lattice, right? But if you add a little water to that guy, then it might soak in through the lattice and you might have a regular arrangement of water molecules kind of stuck in there. The water is not really part of the ionic compound. It's really just kind of stuck in the lattice with it, basically, is what it amounts to. And they're most commonly formed, if you go to a chemical supply house, I guess what I'm trying to say is you'll usually see these hydrate compounds for you to get and to use in your experiments. But usually in nature they're really formed if you have, let's say you have a solution like a pond or something, or like a puddle that has some things dissolved in it, some calcium, some carbonate ions or something like that. And then over time it evaporates, so that when you get down to the end what you're left with is the powdery crystal that's kind of like the result of these two ions that have reacted together. So they were in solution. Kind of like if you go into an underground cavern or underground cave, you'll see the beautiful arrangements of the stalagmites and the stalactites. Well, those are crystalline in nature, and they were at once dissolved in water. Over time, the water goes away and evaporates, but what's left behind is the ionic compound. Well, if you take one of those and look under a microscope, you'll find that inside of the lattice structure of your ionic compound, there's also water molecules there. So if you start out with a dissolved solution of ions and let it all evaporate away, a lot of times what you'll be left with is really a hydrated compound, a hydrate compound, which means it's a regular old ionic compound, but there's water kind of inside the lattice. So the easiest way to kind of get this across to you is to just show you how they're written. So if I have calcium chloride, we've talked about how to name these things, CaCl2. This is nothing special. It's exactly the way you would write it if you just had calcium combining with chlorine, right? But if it's a hydrate, it might have 6 water molecules.